All right, hello. We are back for the second activity in lesson 8. All right, this one, the title is How High and How Low Can It Be? So we have a picture of a basketball hoop. And when they talk about the basketball hoop, they're talking about the rim here, not the very top of it's called the backboard. So when they're talking about up there, they're talking about this this little what they call a rim is right here. That's what they're talking about by the hoop. And so we want to figure out what we think are reasonable estimates for the maximum and minimum heights of the basketball hoop. Okay, so we want to try to look and see what is it that we can see in the picture that can give us an idea. Uh, we're not going to be able to get exact with it, but we can get an idea. So, number one, complete the first blank in each sentence with an estimate, and the second blank with either the word taller or the word shorter. So, let's take a look. When I look at it here, I estimate the minimum height of the basketball hoop to be what? Well, let's look at it and see. What I notice is there is a person that is standing here, right? It looks like it's an adult. Maybe it's a teacher. I don't know. I also see a ladder. um, you may have heard of a certain kind of ladder here. We can see if you look at the steps here. Looks like it might be about a 4-foot ladder, possibly. Um, and then if you look at the person, the adult, I know that most adults tend to be, maybe at least around about 5 feet tall, give or take a little bit. That would be kind of an average height. So I keep that in my mind, and then I look to see where the top of her head compared to the rim. Looks like she is maybe like kind of about halfway up to the rim, maybe a little bit less. All right, so let's if we talk about the minimum, so not necessarily what we think is most likely, but just something that we can say it definitely wouldn't be less than that. I would say it's safe to say that she is not shorter than 4 feet tall, right? So she's probably at least 4 feet tall. That might very well be a 4-foot ladder. And so if she is, kind of about halfway up there, maybe not quite uh, halfway up, it's a good bet that rim has to be at least, I'm going to say 8 feet tall. You can have more than one answer. If you wanted to say, maybe be more conservative with it and say it has to be at least 6 feet tall, you can maybe say that. I'm going to say that it has to be at least 8 feet tall. That's going to be my estimate. You may have a little bit of a different estimate, and that's fine. But I'm going to say 8 feet. So, what it means, if it's the minimum that we're talking about, this means the hoop cannot be shorter than this height. Okay, so if it's the minimum, it can't be shorter or less. So I'm going to stretch this out. There we go. All right, that's what it means if it's the minimum. It can't be anything less than that. All right, and then for the other part, I estimate the maximum, that's the most, height of the basketball hoop to be. Well, let's see. If she is, somewhere around 4 or 5 feet tall, the rim is maybe a little bit more than double that. Let's imagine this. Can we agree that she is definitely not more than 7 feet tall? She is probably not 7 feet tall, but she's definitely not more than 7 feet tall. So if we were going to say she is 7 feet tall, just to be on the safe side, well then the rim, it's a good bet. It's not going to be more than 14 feet tall. So I'm going to put 14 feet here. You probably would be safe even saying, about 12 feet is probably not more than about 12 feet. But I'll go with 14 now just to be safe. I can be confident it's not more than 14 feet tall. Okay? And then so if it's the maximum height, that means that it cannot be taller than 14 feet. All right. So for number 2, it says to write two inequalities. That's using the symbols, which you're going to see in a little bit. One to show your estimate for the minimum height of the basketball hoop, which we describe here, and another for the maximum height described here. Use an inequality symbol and the variable h to represent the unknown height. Okay, so if we look at for the minimum, let's go ahead and specify that's what we're talking about here. Minimum. All right, so for the minimum, we know that it has to be at least 8 feet tall. It can't be shorter than that. So we can say that h for the height has to be greater than 8. Okay? In other words, the height cannot be less than 8. So I would say greater than 8 would be one way you could describe that. And then for the maximum, if it can't be taller or more than 14 feet tall, then we're going to say that the height needs to be less than 14. Yeah, the rim is definitely less than 14 feet tall. Okay, so we don't have an exact measurement right now. If we did, we would use an equal sign, but we just have a picture, and so we're kind of just left to guess based on what we know about how tall an adult would probably be. And if you know about this ladder here, there's a good chance it's a 4-foot ladder, so that would give you a good estimate. All right, number 3. Plot each estimate for minimum or maximum value on a number line. Okay, so we can just use these inequalities here to plot. So h is greater than 8. So we just have a blank number line. So what I would suggest is we need to put 0 somewhere on there. I'll just put 0 here. Okay, you don't have to put it exactly there because we don't have any other values, so we can't be absolutely certain. We can put it kind of wherever we want. What we know, though, is that we need to show that it is greater than 8. So we need to find 8 on here. So if this is 0, this would be 1, 2, 3, 4, 5, 6, 7, and 8. Okay, I forgot to put my marker here. So we can use the text box actually. So let's count one more time. 1, 2, 3, 4, 5, 6, 7, 8. Well, we're going to call that 8. And so if that's 8, and we're saying it really needs to be 8 or taller, then what we can do is we can go ahead and we can draw a little circle in here, a little point, and then taller or more is going to be this way. So I'm going to just come up just a little bit and then go this way and just put a little arrow at the end just showing that the value is going this direction. It's got to be bigger than 8 feet. All right, I'll use a different color for the next one here. So for the maximum, if the maximum h has to be less than 14, then we need to make sure we have 14 on the number line. So let's see here. Why don't we put 0 at the very beginning for this one? See if we can count to 14. So let's try for 14 here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so we'll call that 14. But we're saying that for 14, it needs to be less than that. So we need to come in with our marker, and we can circle 14 and go up a little bit. We need to go this way. This way is less than. So less than 14. So that would be how your points would look for the number line. Again, you might have a little bit different values here. That's okay. You don't need to have 8 and 14. All right, number 4, suppose a classmate estimated the value of h to be 19 feet. Does this estimate agree with your inequality for the maximum height? Well, we were thinking probably more than 8, but probably less than 14. So 19 is a little bit kind of a wild guess. That does not agree with our estimate. It doesn't seem to make much sense for it to be 19 feet. Well, you can think about it right here. If it was 19 feet, if she's kind of about half of the height of this and close, then that would mean she'd have to be about 10 feet tall, right? Because 19 is a little bit less than double. She's not 10 feet tall. So that would be a silly guess. And then for number 5, you're just working with your partner and you're comparing your estimates.